Good morning, my name is Agata Fialkowska. In this year's design studio, we are looking for solutions to water problems in the Campine Plateau region. My answer to this challenge is titled Water Center Neighborhood. Through my design, I want not only to solve water issues, but also raise social awareness about the water problems. My pixel is located at the eastern edge of the Campine Plateau, in the town of Maasmechelen. The town is located between the Campine Plateau and the Maas Valley. It's based on sandy soils, and the largest area is taken by the residential terrains, with majority of single-family houses. Current water system is based on sewage. Water is extracted from the ground, sent to the houses, to the treatment plant and to the river. Large ground extraction, together with a lot of pavement, slows down the aquifer renewal, increasing the water stress in the region. The question is, how can we make the water management system in Maasmechelen more sustainable? How can we treat water on site and let it infiltrate within the city instead of sending it to the river? To answer that question, I started by looking for available resources. As many villages in the Campine region, Maasmechelen experienced intense development in the second half of the 20th century. The car-oriented development created a characteristic grid of streets and built-in sectors with leftover green spaces between them. Although it's not as visible as before, we can still see a lot of larger green spaces cutting through the city. It gives the opportunity to introduce elements of the decentralized water management system as well as green public spaces. To guide my design, I used 3 research questions. The goal is to create a centralized, sustainable water management system. To achieve that, I needed a way to clean and discharge water on site, a way to connect green spaces, and social program to engage residents, as their participation in the process is crucial. I used constructed wetland as a way to clean water on site. It's the technology based on natural wetlands. I decided to combine different types of wetland, vertical flow and horizontal flow, to achieve the highest possible efficiency and biodiversity. To determine possible location of the wetland, I took into account existing sewage system, availability of space, terrain and number of households. As a result, I found 3 most suitable areas located within Greenbelt and next to the school, which creates natural center of the neighborhood. I chose one of them for the final design. I did some estimation for the elements of the system. I used an anaerobic baffled reactor as a primary treatment. I use it because of high efficiency and safe closed structure that can be placed underground. To link green spaces next to the schools, I decided to transform one street into more pedestrian-friendly. Rain gardens along the street allows rainwater to infiltrate into the ground. On the way to school, children can observe elements of the water management system. Large green space next to the 2 schools will be transformed into a public park. Design of the park will be based on the terrace structure of the constructed wetland. The park will be divided into several zones with different activities for children and other residents. By combining the 3 elements, water management, linking green spaces, and social infrastructure, I want to create a new water-based center of the neighborhood, where residents, including the youngest, can spend their time and learn about the water system. I made this concept diagram to guide my design. Here you can see the final design. As I mentioned before, the park will be divided into different zones based on structure of the constructed wetland. In following slides, I will quickly introduce the most important parts of the design. The bridge pavilion is a place where old sewage system meets the new one. The central part of the pavilion is where children can observe water experiments and maintenance reminds of the anaerobic buffered reactor that is placed beneath the pavilion. There is also a multifunctional room that can be used for school workshop, meetings of residents, and different events. The main part of the Wetland Park is inspired by this map from 1712. I tried to imagine how original landscape of the Campine Plateau with small streams, patches of woods and wetlands might look like. The lowest part of the park is the discharge zone, where water is infiltrated into the ground through small streams and shallow ponds. It's also a huge playground where the youngest children can experience their first encounter with the water system. To finish off my design, I added a few more elements. A parking with permeable surface for the schools and the shops, a sports field for children that also collects excess rainwater from the parking, and a green bus stop next to the schools. My proposal is just the first blue dot on the green belt of Maasmechelen. By combining several water-centered neighborhoods, we can not only prevent future water problems, but also preserve those green spaces for the future generations. Thank you.